blessings of Almighty, I start this session by inviting our Vice Principal, Mr. S. Ramasamy sir, to deliver a welcome address. Over to Ramasamy sir.
Thank you, ma'am. Good evening. I am S. Ramasamy, Vice Principal, Maharashtra Women's College of Arts and Science. I take immense pleasure in welcoming all the outstanding academicians that have gathered to this international webinar. This lockdown time, which help us to enhance our knowledge. I welcome our chairman, Mr. S. Kunjidabadam, and our managing directors, Mr. S.K. Thiruman and Mr. S.K. Sendil Kumar, who has offered us a motivation in conducting programs as this webinar for our benefit. On behalf of all the staff of our institution, I welcome our resource person, Mr. Sendil Kumar Ramasamy. He completed his BSc Computer Science, Nehru Memorial College, Puttanamatti, Trichy, MSc from College, Tanjavur, in Bharathasan University. After post-graduation, he took his first job as a lecturer in Computer Science Department, Nehru Memorial College, for 6 months. Then he moved to IT industry, BHS Data Center, Chennai. After that, he took his journey to USA. From 1999 onwards, he is working manager, software engineering, Amaranth Corporation, St. Louis, Missouri, USA, who has consented to grace this occasion with his presence. I thankfully welcome Sendil Kumar sir. I welcome our principal, Dr. Mrs. N. Boma, without whose able leadership and guidance, we would not have possibly executed many such good initiatives. I sincerely feel proud in welcoming Mrs. R. Jodi, HOD, and faculty members of Computer Science departments of our college for their most sincere presence. Last but not least, I would like to extend my greetings to some of our beloved friends and fellow academicians from other colleges who have spent their precious time with us during the busy time. Once again, I welcome you all. Thank you. Thank you, ma'am.
Thank you, sir. Thank you, sir. I feel blessed to invite our. Yes, thank you, sir. I feel blessed to invite our principal, ma'am, Dr. N. Uma, to deliver a special address. Welcome, ma'am.
Good evening, one and all present here.
Welcome you all. Thank you.
On behalf of MWC, it's really, it's our, memorable moment now to organize, for the Department of Computer Science.
Our principal ma'am, Dr. N. Uma, to deliver a special.
Good evening, one and all present here. On behalf of the MWC, and with the blessings of our chairman, and with the support of managing director Mr. Thirukumal sir and Sendil sir, our college has been organizing so many webinars. Hope I am audible.
Yes, ma'am, audible.
Yes, ma'am.
And it cannot go out, and so the patients who difficulty in breathing, they have coughing, chest pain, headache, fever, and also fatigue.
Participants are asked
Under
to.
more serious complications, respiratory failures occur only with the help of ventilators.
Participants are asked to mute themselves.
Yes. Shall I start?
Ma'am.
Good evening, one and all present here. On behalf of MWC, with the blessings of our chairman, Mr. S. Kunjithapadam sir, and with the support of our managing directors, Mr. Thirkumaran sir and Sendil Kumar sir, we have been organizing many webinars at a national level and international level. And so, for all this, only the Department of Computer Science department has been a pillar of support in all the technical, support. Amidst so busy, I congratulate Mr. Ramaswamy sir, our vice principal, and Mrs. Jyoti, head Department of Computer Science, and the team of members for wonderfully organizing this international seminar. And way to go. Really, I'm very blessed to have all our staff members and the management who are doing extraordinarily. They are just finding out the opportunities out of the challenges, and they are doing their best. And I wholeheartedly, again, on behalf of MWC, thank our, the speaker of the day, Mr. Sendil Kumar sir, who has been consented to address the participants. Thank you so much, sir, on behalf of every one of us. Looking forward for your address. Thank you.
Thank you, ma'am. I request Mr. Sendil Kumar sir to take over the technical session. Welcome, sir. Thank you. Sendil sir.
All right, are you able to hear me now?
Sure, sir.
Okay, that's good. Good. Thank you. Namaste. Thank you. So let me try to share my screen and we can walk through the slides. Able to see the screen?
Yes, sir. Yes, sir.
Okay. All right. Good evening, everyone. I know it's been a pleasure meeting with you all today. Thank you for the nice introduction. Thank you for the welcome address. I really appreciate every one of your time. So as principal and vice principal and other folks noted down, my name is Sendil Ratnasabhavati. I'm working as a manager in a software engineering department in Amaran Corporation. That's one of the utility company in supplying power for both Missouri and Illinois. I had a wonderful opportunity back in India to go for higher education in computer science, both undergrad and postgrad. And then after that, I had a very short period of time. I worked in Chennai, and of course, I worked in a college where I got graduated to. So and then I moved on here. So I'm here for the last 21 years. Certainly, as you all know, the software industry in the last 25, 30 years went through gyrations of the development overall. Day by day, it's getting bigger. Day by day, it is getting innovative. Day by day, it is getting enhanced. Every day, whatever comes out, the next day it is outdated. So software delivery is also basically went through iterations of changes. So the topic what we are going to go through today is CI/CD pipeline. And I'm really sorry I cannot judge all of your ability to understand, because some of you may be in the very beginner level, some of you may be in the intermediate level, some of you may be in a very advanced level of software industry. And I have to make the presentation or the content of the slides, which is basically applicable for all of you. When you go for any speech or anything, you can usually poll the audience, the level of understanding. And if there are really a lot of people are in advanced level, you can actually tailor the slides based on the audience. Whereas in this case, I'm not able to judge all of your understanding level. So I have made my slides to be applicable for anyone who is a beginner, anyone who is intermediate, anyone who is really advanced. So if some of this is repetitive for you, please forgive me. And if it is something good, you take it from this out of 10, 15 slides, whatever I'm going through, and in another 30 to 40 minutes of the talk, anything you can take it, even little bit of things, that will be wonderful. So please, at the end, definitely share your concerns, feedback, and question and answers. I'll be able to answer. If I cannot, I will get back to you later. So without further ado, let me get on to this. And here is the agenda which we are going to go through. Stages of application development life cycle, and application development regions. How when an application, computer application, gets generated and developed and deployed, what are all the stages involved there, and how the industry, the computer industry, went through some kind of a thought process behind this, and how they can automate this steps, and how they can improve the steps. That's what the concept is, CI/CD. It's called continuous improvement and continuous delivery, continuous integration and continuous delivery. And what does that pipeline means? In general, pipeline means, you go to manufacturing industry, you have seen, how the things are manufactured, just they go through the pipeline. So basically the software development is also going through the pipeline nowadays. And we are going to see that in the picture, how exactly it looks like, and what is the current trend, and what is the future look like, and even my experience, what I am working with my team. That's what we are going to look at it. And then after that, what is the benefit of this? Anything we do, no matter what, it's supposed to yield some benefit. Otherwise, we cannot do it, or we don't want to do it. So what are all the benefits of the CI/CD pipeline, which we are spending a lot of money? Companies are spending a lot of money to do that, and they're improving also. So what kind of benefits it yields to the company? And anything what we do, we need to ask series of questions against that to understand how good it is. Is it really good right now, or how we can improve from where it is now? And that's we'll find out what kind of questions we need to ask to understand the CI/CD pipeline and to make it better. And what tools we use in CI/CD pipeline. So these are all the things we are going to look at it. And so this is a very high level slide, and it may be very basic for some of you, or it may be repetitive for some of you. So as I said, just bear with me, go through the slides, and please listen to me what you have. And of course, store your questions. I will definitely answer at the end, going through the chat box. This is the stages of application development life cycle. And if you look at the software industry, I was in the higher secondary school back in 80s, and then in the college in 90s, and then in the school in the job market late 90s all the way until now. And this application development life cycle also expanded a lot. So you want to build a commercial application. Before 80s, the computers are used only in the scientific industry. Now the computers are used across all the industry. No matter wherever you go, including the agriculture, you are using computers. Including each and every device you are playing a day-to-day life, you are using computers or microprocessors inside it. So once upon a time, the languages are used only for scientific purpose. Then commercial purpose, when they started using it, the development became a very big situation, and they have to maintain the life cycle of it. So what does it mean by application development life cycle? First of all, you sit with the business customer, you understand their requirement, you are collecting their requirement. What do you want to, what is their pain? So you go to an accountant, they say, yeah, I need to just create a balance sheet. I need to create a profit and loss statement. These are all the accounts, what we do in our accounting firm. So you go to a manufacturing industry, they will give you their own requirements. So like that, you understand and collect the requirements, and you put it in the computer instruction and a language, and you build it. And then you do the unit test. So that's where each and every developer, they are doing their own unit test. and then you do the system test, and then you do the UAT, user acceptance testing, because I work in a team where we have 300 people touching the code every day. Every minute, there will be some code getting changed here and there. So the user acceptance testing, and then user acceptance testing gets signed off, then you are implementing in the production. So that's where the business users getting the use of, the use of the application. Until the time you are going through gyrations of this, these stages. So that's very important to understand this application development life cycle. You collect the requirement, you build it. Build means you are writing the source code, and then you are testing it. It's a unit test, only every developer tests it. And then after that, you are giving it to the users so that they can test it. And then after that, you are implementing it. Until that time, the accountant or manufacturing or your business customers are waiting. So once you implement it, they find bugs, and you have to fix those bugs, and you have to issue the version of the software like 1.1, 1.2, 1.3, like that. So that's how every software development life cycle works. And in detail, if you look at each and every step, what are all the steps involved in this life cycle, application development life cycle is, when you collect the requirements, you are showing some samples, you are creating some documentation, and then you are creating some prototypes, you are creating or drafting some design ideas, and you are showing to the user. Do you want the screen to look like this? Do you want the report to look like this? Do you want the input fields like this? Do you want the output field like this? So you went through a series of meetings with the business customers to understand their requirement. And then you sit down and then plan for it. You want to plan, because it's not a simple simple software development anymore. It's getting complex and complex. And I kind of worked in the last 25 years, 22 years I'm here. I worked in the largest client server application in the industry. So you create wireframes. Some of you may know what wireframes is. It's nothing but a prototype. And you create specifications, you create design documentation, you create project plan, and you align the resources, you find the right talent, you assign all those people with the amount of work, what we are planning for it, what we are trying to build it. And then after that, you find out the business wanted it, January 1st. Once you load all the resources and plan for it, you are not able to deliver by January 1st. So you add more resources to it, or you cut the scope of some of the things what the business customers wanted. So once you plan for it, okay, all those things are some agreement between you and the developers, and then as well as the business customers. And now you are building it. Now this is where the software developers, the real developers, get into action. They do all kind of coding. They do wonderful design. They have a lead role. They have an architect role. They have coders. They have system engineers. They have a different kind of roles there. It is quite interesting when you get into that build mode. And I'm basically I was a software developer, not anymore, but I kind of manage the team of developers. So, I still understand what's going on in the industry so that I can just manage and lead the team properly. So that build, that's a wonderful place, where developers get very excited, and they work day in and day out. And I know when I was in India, I just worked day in and day out, and I enjoyed that, the programming part. So you build it, and then after that you test it, and then you implement it for the people. Testers also, right now it's getting big. It's called smoke test, dress rehearsal test, and user acceptance testing, system testing, all kind of testing. There are different varieties of testing. Even testing, right now you have separate courses to go through that. So then after that, you are implementing it. Once you implemented it, now it's not something business or the customers who are getting it. Sometimes they may feel unhappy. This is not the one I wanted. You gave me something totally different than what I wanted. So you have to take that feedback back to the very beginning stage, collect the requirement again, create the samples, and then create a documentation, plan for it, and then again build it, and then again implement it. So now business, oh my God, now it looks good. Now I need to improve from here. I need more reports. I need more screens. Now my business is also getting bigger. I need more and more business functionalities in this software. They are so excited. Now you take that feedback back, and then you get it requirement, and then plan, build, test, and then deploy it again. So this is the life cycle. You will never get out of it. It will get interesting. I'm working in or at least in the last 20 years, I've been 2 applications. It never ends. It never ends. It keep on going. You have different projects in the same application. That's how it gets in there. The next, as you understand the development life cycle, now look at the development and deployment regions. These are all the regions where we in the big companies they use before they give it to production. Developers work on a development region, and then once it's ready to test, they test. There are 200 developers working on the code, and they are ready to, they test what they did, only their own particular module. And once they develop and test it, that's called unit testing, they move to another region called the QA region. That is where quality testers, they do the quality assurance and quality testing and all those kind of. Once testing is done properly, or maybe there are some test scripts and test cases failed, it gets back to the developer and they fix it and come back to QA again. Now the code is moved from QA to staging because it passed the testers. In staging, that is almost pretty much the region before production. In the staging, it's all ready. It's all ready for the prime time. It's all ready to go to production so that business customers can do. In the staging, they do the final round of testing, which is called user acceptance testing. And then from there, once the user accepted, yeah, I need this. This is what I wanted it. You're done. Now give it to me. It goes to production. So in the production region, that's where the business customers or your clients, they access the application and they use it. Throughout this, right from the beginning all the way to the end, the people are still working on it. People are working on it, but it's in a different region. You have a fence between this. I'm pretty sure some of you work in a big companies or some of you work in a big lab and they have somewhere similar to this, if not the same thing. And there are a lot of other stages in between. This is as simple as I can make it. So this is the deployment regions, how the software application getting developed and then moving across the region for the people to, or the business customers or the clients to get used to. So these are the 2 main things in the high level. You need to keep it in your mind, to further go along in this topic. So application development life cycle, the stages in that, and application deployment regions, the boundaries and stages in that. So now let's get on to what is CI/CD. Here is where the main topic is. And it is definitely near and dear to me because I implemented or helped implementing this in my company. As you go through back here, in this, you plan, you build, you give it to the clients, and then they give bad feedback, and you come back again and then collect the requirements, plan again, build it again, give it to them. These are all done manually. Everything is, I remember, or at least all of you can remember how we started our life with the BASIC and Fortran and Pascal and C. You compile using a floppy disk and then you just give it to the people and they test it, and that's how it's done. It's a manual process. Whereas the CI/CD is continuous integration and continuous delivery. Of course, some articles says that it is a continuous improvement also. And that is true. Either you can take it as an integration or improvement, both are pretty much same. So developers, they are writing the code. They get immense pleasure writing the code, and they get immense pleasure to troubleshoot when there is a problem. They get immense pleasure. They when they deliver the application and the client is very happy about it. They are very much focused on it. You tell them to compile it, they may not compile, but if the compiler gives error, they will be ready to fix those problems, but they don't want to sit down and compile and go through all those kind of process. And the delivery is also like that. Okay, you know what? And I have developed all these things. And when I was in Chennai, I take the floppy or I take the CD back in late 90s or mid 90s. I go to the client and then install it and then explain the features and then, and then he gives the feedback. I come back to the office and then fix it or just improve it. And did I like it at that time? Maybe it's okay because we don't have anything. But now we have a lot of applications and tools, which we will get to see that at the end of the slides. We can automate all this process. And developers are very much focused on writing code. I mean, if you are a developer, you will be extremely happy about writing code. I don't want to sit and compile and look through the errors. I'm really happy to fix the errors, but I don't want to look through the errors. And I don't want to just go and install using auto execution batch file or install that back, that is back in 1890s. And then now it's, so many other installation procedures are going on. So CI means continuous integration. Is a software development practice in which all developers merge code changes in a central repository multiple times a day. So what is it? I'm sure some of you may be really familiar with source control system. There are a lot of source control systems, Visual Source Safe and Microsoft Teams Team Foundation Server. Team Foundation Server, TFS, PVCS. There are so many source control systems the companies use because the code is getting, millions and millions and millions and lines of code right now. And there are 200, 300 software developers work in the same application. So it's almost like a library. You have a library and you check out books and you check in books. You check out and you read the book and check in back again in the library. So same way, you check out the module from the source control system, the developers work on it, and then you merge the code back into the source control system. And then a compiler compiles it. So that comes the next, and that's the source continuous integration. So you have Team Foundation Server installed or maybe provisioned by cloud, and you have all the code is there. The developers checking out, working on it based on the requirement and checking it in back. And that's it. That's what developers get excited about. They want to write code. They want to write code, understand the requirements, and they want to write code. Now, this is continuous integration. The next is continuous delivery. What does it mean, continuous delivery? So versions are getting big. It's right now you can see the Microsoft Windows, okay, my operating system, Windows 10. Windows 10, that's in the high level. But you go down to the help screen and you may see Windows 10 version 1.17.4, 4.5. build 1234. So all those numbers are the delivery mechanism to track in the tools. So that's the delivery what these companies use. And it is again, it's a system, automated system. When the source code gets checked in the TFS or any source control system, it triggers a pipeline and compiles it, and then it gives the source code errors and then gets back to the developers. They fix it, and then again it goes to the testers. They test it. Is the problem? Then come back. Everything is automated. So everything is automated. No manual intervention. So let's see how it is. So that's what CI/CD is. CI/CD pipeline, let me read that without diluting the statement. It helps you to automate steps in your software delivery process, such as initiating code builds. So you have to run the compiler to build the executable. Either case, as a developer, we all know we have to compile it. We have to compile so that the computers can understand the machine language. It can understand only zeros and ones. It can understand only the binary language. So we have to build it as an executable. So it has to initiate. We don't have to initiate. the tool will initiate. How does it initiate? If the developer checks in the code, it gets initiated, it just compiles, and it runs the automated testing. The testers, they put all the scripts there, they monitor how exactly it is testing it. If you are manually testing it, it will take months and months of time. So everything is inside the tool, it automatically tests it, and then it automatically, if the test cases are passing, it automatically deploys and staging. There the users come and they may have testing tool. It depends on the companies, depends on the size of the application, and it depends on how much money they can spend on that. Either they have automated testing or they have the client sitting manually and then testing. And if the test cases are passing there, it gets to production deployment, production region automatically. So all these pipelines are very, 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 very independent, and it is automated. It is not something someone has to sit down and then they have to click the button to make it work. Everything is automated. And this saves a lot of time for the customers as well as the companies. And this saves the developers can focus more on coding rather than compiling, rather than testing it. Even the testers, they can do more than testing because the tools are there to test it. So that's the main concept of CI/CD pipeline. It continuously improving it, it continuously integrating with the software development tools, and it is continuously testing and delivering it, deploying it into the region where people and customers and business, they can do it. Let's take Amazon.com. You all buy maybe things from Amazon, and there are a lot of other sites, they do those kind of things. They never go out of work. I mean, the site is up and running. They always up and running. It's basically, they use CI/CD pipeline. There are tons and tons of developers work, but they don't involve in any of those things. They have separate department, but at the same time, they have strong tools to make it automated so that they more focus on the quality of the code rather than babysitting this the manual process. So as it says, it provides standardized development. We can look at in the benefits. So here is, I know these slides can be distributed to all of you also, so that's why I put it in there, but I hate to put a lot of information in the slides, and I tend to talk too much when I get to speech. So it's basically, as I explained, developers, they check in the code, they check out, they work on it, they check in the code, and it triggers a branch because everyone is working on different features. There are 200, 300 developers work on 20 different projects at the same time. So there are branches getting created in the source control system. Developers check out and they work on it, they do the unit test, they check it in back, they commit inside the source system. And then after that, it creates the build. It automatically initiates the build. Once the build is getting initiated, it goes to a next region. It's a QA region. There, the testing tools comes down and it tests it. All the testing criteria, cases, scripts, all the things are loaded in the test tool. And then from there, it just getting tested. QA people are watching it and seeing what kind of things are failing. Once it fails, it goes back to the developers automatically. And they look at the feedback, and then they have to again check out the code and they work on it and then check it in back, it creates. And as you know, the compiler may give some errors. And when it gives the errors, it comes back, and QA gives the error, it comes back to the developer. It's a continuous feedback coming back to the beginning of the stage. And then it gets, worked out automatically. And then it just gets back. Again, the developers, that work is not automated. Developers are still, they have to put their mind and they have to use the proper code and they have to test it. There are some tools, it creates a bunch of code and you can go bunch of help, like in Visual Studio, they have IntelliSense, another feature. It's a simple one. Like that, there are a lot of other tools. It creates a cluster of code, you can use it. But again, nobody can beat this. You have to make your brain work. So the things are fixed immediately, and then it just get back to the QA and get back. All these things goes back to step 2 again, and then comes to all the way down. And until it goes down to the production region, the steps are automated. It's a continuous improvement and continuous feedback. Here are the benefits. When we build these automated pipelines, you reduce manual errors. Human error is one of the main cause introducing bugs in the software delivery. So if we take, I'm pretty sure some of you are familiar with ITSM. That's another concept. It's called Information Technology Service Management. And it is ITIL practices what UK brought it up, and then they instituted across the world. And they go through all the issues. They have incident management, service management, change management, and problem management, and configuration management. Like that, you have 32 different managements when they develop the software. When you take the incidents, one of the main cause of the incidents happen in the software, which is bugs, are usually due to human errors. So you can remove those kind of human errors using this automated pipeline because it's automated. Of course, you set up the automated pipeline. If you make a mistake in the beginning, it's going to bring all the bad things, So it reduces, and then it gives a standardized development feedback loops. Every stage, it's getting tested, or the feedback is coming back to the developer. So now developers are more focused on giving the quality code. There is no, no files moving from one table to the other table, or it's not coming to the inbox. It just comes everything in the tool. And I will show you the landscape of the tool, then you get to see that. I'm sorry, it's not a demo. It's, this is more like a kind of a lecture, and it may be dry sometimes because if demo is there, definitely it will give more context to it. But you feel free. There are a lot of YouTube videos on this topic. There are a lot of articles and a lot of labs set up by companies also. You can access that. So developers can stay more focused on writing code, and then they can give the quality code at the end. They don't have to test. They don't have to wait for the feedback. It comes everything quickly. Product updates are not stressful. And that's nothing but, once you develop that to the client, and then the client is looking at it, this is not, I wanted the, things like this, but this is what I was telling you when you collect the requirement. So now you need to update it quickly, because you don't want an upset client walking out of the door, and you have to maintain this client. So you have to update it quickly. How I'm sure you know about agile methodology. So you have to be very quick. So the update should be very, very, very quick, and it should be stressless. It's just make it very quickly. Oh, this is what you want, I can make it. So now you go back to the developers, and then they do it like this, and it gets to the testing, and it gets to the production immediately. Locks all code changes. So here is the very important thing in the source control system. Every change, it changes, it locks, it goes back, and it is maintained. Only the final changes are getting released, tested, and went to the client. This is a very important step in the recent past, at least in the last 10-12 years. Some of you may know the financial problems came in 2008, and a lot of companies went bankrupt, and it was one, extremely, nobody can think about that kind of a fall off in the stock market, and it reflected everywhere across the world. And they realized it, the software applications are basically faked up, creates bad balance sheet. They booked the, they made numbers, and they made it like, this software company made money, or any companies made money, and they just make some kind of a fake balance sheet. So, and then they blame it on software. Oh no, this is what it happened. They got a bad code or whatever. So how was that code back in October, back in September? How was that code? So every code needs to be, every code change needs to be logged. So they'll go back, and then they find out where the problem was. And auditors, right now we have more auditors in the companies than developers, because they audit each and every code changes. And they try to find problems in the application and then they try to make improvements there. So that's very important, and that's the reason we have source control system, and then it just logs each and every change. And that helps in the next bullet point, rolling back to a previous version in the event of a problem. So any changes gives bad thing. Immediately, oh, last time what you gave me is better than this. Or you can go back to the last one quickly. How can we do it? I mean, you cannot compile and store it all the time. At least you have a previous version of the code, build it immediately, test it quickly, and then go to UAT and the user acceptance. They look at, oh, this is what I wanted. Just release it. You can save the previous versions in any memory, but companies don't do that because memory costs a lot also. And I'm pretty sure if you work in a big company, they try to come up with a lot of options to save money there. So these are all some of the benefits on the CI/CD pipeline. Let me check. I think there are 15 more minutes, I believe. So stop me anytime, organizers, if I'm talking too much, okay? These are all the questions you answer when you think whether you build a good pipeline. And of course, whenever you do something, you have to make sure you are delivering it properly. And you have to make some, check here and there to make sure it yields the process, or it yields what you really wanted. How quickly do we get feedback on the correctness of the work? That's more important. I mean, if it takes more time to get back the loop, the QA people are testing it, get back to the developers, it takes like weeks or days, then it's not going to be helpful. How quickly you are bringing it, you need to invest more time there. How long does it take us to build, test, deploy a simple code commit? You're just making a punctuation change, and immediately it triggers the code, build and then test it and deploy it. That's simple. But you are making complex software changes, 200 people making a change, and then you check it in. When you check it in, of course, you have a lot of code conflicts come. And the code conflicts needs to be solved by the tool itself. Sometimes the tool does it. You have built-in algorithm in the tool to make it work. And then our CI/CD pipeline scale to meet development demands in real time. So this is where the cloud comes into place. It needs to scale up and down. So what does it mean? I mean, it's basically agility built into the pipeline. Sometimes you have 1 or 2 clients, your company has only few pipelines, you are able to build it quickly. And there are suddenly your products are very successful in the market, and you are asked by so many companies to provide that application or software, then you need to scale up quickly. You need to build that pipeline very quickly. And most of the companies, that's where they go for cloud, because cloud is, they invest money more on scalability and reliability. And the companies doesn't care about, okay, you know what, let me pay the money and they can do whatever they want. And then they can scale up. That's how they made that agreement. How quickly can we set up a new pipeline? It takes years to set up the pipeline. It takes years for the developers to get trained. It takes years to get into the culture of constant feedback coming back to the developer. It is not that simple. And I've been in the CI/CD at least for some time in the last few months, and it takes a lot of time to get matured after that. And reliability and accuracy, of course, it should be reliable. If the compiler fails, if the testing tool fails, if the deployment tool fails, if a region completely failed because of some environment problems, the pipeline is not used anymore. And you have to keep on making sure, investing money on making it reliable. And accuracy, of course, you hear about false alarms, you hear about a bad error comes out, but when you go back and troubleshoot it, it's not an error anymore. And because the compiler gives the bad error. But those kind of things, accuracy needs to be built into the system. Rolling back to the previous version in the event of a problem, that's a push button. You just push a button, it goes back to the previous version of it. That's where, if you look at in the help screen in most of the software, you have version, 1.1.2.3. Build, some numbers will be there. So they just quickly go back to that by clicking on a button. And of course, all this phones, they have, automated software delivery. You turn on, your iPhone gets updated, your all other phones, Verizon or anything else you think of, everything gets updated. And if something screws up, they go back to it quickly. So in the pictorial view, this is how it looks like. You are committing the change. It just triggers the build quickly and it builds. That means it compiled and it creates the compiled code, the binary, and notify of a build outcome, what kind of syntax error, semantic error, or anything best practices violated, or any code standards violated, or anything needs to be improved. Now, cybersecurity is a big concern. Is there any vulnerabilities and all those kind of things? Some static scans, dynamic scans, you can do that in the build itself when it comes out here. And then it runs the test in the region, and that's where, when it comes to test, you come out of all the compile problems. And now here in notify the test outcome back to the developers again. Everything goes back to the developers very quickly, and then it develops the build again, and it goes to the environment and production. So here is the tool landscape of all the things what we use. You may be you might have come across a handful of application languages, scripting languages, in your courses. Basically, you have C for scientific application, Pascal, still uses in ISRO and all kind of other scientific places, and then you have Visual, Basic or C#, those kind of things, RAML, SAML, and all those things, the scripting language, markup languages. These are all, handful. Maybe you may know like handful of the languages, you're really good at it, like Java and other things. Tools are so many tools in the industry now, and it's an IDE, integrated development environment for you to develop, or anything else, basically to produce the application for the customers. We have so many tools, especially in this space, in the CI/CD. A lot of companies researched and then introduced tools, and some of the tools are very funny names too. Let's look at few of them, and I'm not going to go through each and every one of them, but this is a good slide for, all of you can research further, or some of you may be using this in your company. So if you look at the top, Swimlanes, Collaborate, these are all the tools to collaborate in that. For application lifecycle management, there are a bunch of tools, and Jira is the first one. We use it. I'll try to take it here. And if you go to communication and chat, we don't use any of this, but some of the companies use certain things, and we use Skype, and we use Microsoft Team, and knowledge sharing. And Confluence is the one we use. Confluence is very powerful tool. It's basically, it stores all the knowledge. Developers doesn't have to just run around and talk to the people. It just comes back with the previous problems and things like that. So here is the build tools in this Swimlane. GitHub is the main tool we use in our company, and it's one of the leading industry standard tool. That's a source control tool. And if you see, some of the names are really funny: Bamboo, Cafe, Gulp. If you come to testing, you have a bunch of tools. Selenium is one of the industry standard tool. We use that a lot. And if you come to deploy, we use Jenkins. We use Octopus, we use Deploy. It depends on the applications. We use Sprinkler. It depends on the code environments too. And when it comes to run, it is where Jenkins and orchestration and all those kind of things. And if you look at the business intelligence, we have Splunk, and that stores all the logs in one place, and you can see the issues and all the things together. So when you see the issues in Splunk, it takes you to Confluence back here immediately. If you see the error, if another developer got the error, and if he fixed it, and if he documented something, it goes back to Confluence page very quickly. And you get that a hint very quickly, and you can work on it. So that's how these tools are lined up. This is the, all the tools in the industry, but there are only 1 or 2 every company is using this Swimlane. So I think we are right on time. We have 8 more minutes. With that, I will stop talking.
Yes, sir. It was a wonderful session. Maha ma'am and Gautami ma'am, you can take over the question and answer session. Is there any questions?
Sir, I would like to raise one simple question, sir. I just want to know what is the use of Docker?
Oh, that's very, I think you are very advanced. Whoever asked the question is really advanced. Docker is, let me go back to the slides. It may be easier. So here is the application development regions. In the development region, you have things you develop and then move it to QA. In QA region, they are testing it and then it moves to staging. What happens, there is a configuration in development region. It may not be the same configuration in QA. So maybe if I make it simple, you have Windows 2003 server in development, whereas in Windows 2003 different version of the server in QA region. So the configuration is a little different. And you may see in development it is working fine, but in QA it is not working. And it may be the same problem in staging. In development it is working fine. The developers get confused. Oh, it's working. When I tested it, it's working fine. Whereas in QA it doesn't work. Whereas in staging it doesn't work. Sometimes it works in all 3. When it goes to production, it doesn't work. So the Docker, it containerizes the configuration, whatever is important, in one single package, and then it goes to QA. And that's what Docker means. Docker is it's a tool, or it's a concept. Containerizing is a concept. It containerizes everything together in a single package, and then it just goes to QA. Now, whatever you tested in dev, you are guaranteed you're going to get the same result in QA. You will not have the region problem. So containers, that's a totally a different topic, but it's a wonderful question. It's Docker is a company, they introduced that tool. Google also introduced something called Kubernetes, and that's also same thing like that. It all containerizes the application in a single capsule. Everything what is needed, it will be in one big container, and it just moves to QA. Whereas when you build the code, it builds only what you compiled or what you wrote. Whereas a container, what it does, it containerizes all the things. You may use a feature in Windows. You may use a feature in one of the library which is not in QA. You may use a different version of library which is not in other region in production. So here everything containerized in single package and delivered to the other place. That's what Docker means.
Thank you, sir. Thank you very much. Few members raised your hands. Participants, few members raised your hands. If you have any questions, I'm trying to unmute you. Yes, Maithili ma'am. Do you have any questions to ask? Can you please post it in the chat box? Yes, Maithili ma'am. Yes, Maithili ma'am. You have raised your hand. Is there any questions to ask? Okay. Okay. Gautami ma'am, over to you. Is there any questions in YouTube? Hello. Hello. Sir, there is a few more questions. Shall I ask?
Yeah, sure.
Fine, sir. Can you please differentiate about the tools what you have mentioned? Like a risk management tool and then software re-engineering tools.
Risk management tool. I'm not sure where I touched it. Can you elaborate the question a little bit, please?
It has been posted by the participants. Once again, sir.
Sure.
So they just asked about differentiate about the tools, risk management and then software re-engineering.
Okay, I don't know whether I said risk management, but I think I know what I said as a management. Basically the ITIL infrastructure, information technology infrastructure library that is introduced by UK and that's across the world. We started using it as a software development lifecycle. That's where there are 5 different management: incident management, configuration management, change management, and knowledge management and service management. So that pretty much defines how the services should be kept in the best practices, industry standard level. So I'm not sure about risk management, and I think if the answer is not appropriate, maybe I think I may have to ask the question again. Sorry. That's
No,
where I kind of used the management. Otherwise, the main tools what we discussed so far is here. It's basically you have this 5 different swim lanes: collaborate, build, test, deploy, and run. So these are all the tools used in each and every one of the swim lane. You look at the collaborate, we use Jira. That's where all the application bugs and everything. It's a work management tool. And then this is a source code management tool, GitHub, and this is a testing tool, Selenium, and then this is the deployment tool. Deploy is the one we use, Octopus we use, Sprinkler, and then these are all to run. Kubernetes here. I think Docker is also somewhere here, and then Jenkins is here. So these are all the tools what we use. And here is the cloud tools in Amazon, AWS. I'm pretty sure most of you are familiar with it.
Thank you, sir. There is one more question from the participant. Dr. A.M. Saravanan sir raised one question. Nowadays, programming is replaced by cloud computing. What will happen to programming in future?
The programming in future is going to be extremely interesting. So it is no one is going to take this, no doubt. Okay. And there are so many tools can come. There are so many other concepts can come. It is going to get interesting in the future. It will be robotics. Robotics are getting over everywhere. And you go to the grocery store, you have robots taking up the stock and other things. Then now high school kids are doing, robotic concepts. So cloud is just infrastructure. Cloud computing is taking over because of the storage. Cloud computing is taking over because of the reliability. But no matter what, the computer world is going to be very much interesting day by day. There's no doubt about it. It's the future is very interesting, and be open for changes. That's more important. If you are not open for changes, you still want to stick with the old things, then that will not be interesting. Cloud will take over. Nobody thought the web is going to take over the world 10, 15 years back. And nobody thought, there is something, a cloud is going to come. Nobody thought the mobile computing is coming like this. Who knows? I mean, this phones are, right now, all these teenagers are using a phone. Everything is in the phone. I'm an old school. Maybe I'm still using the laptop, but the teenagers are using everything in the phone. Everything goes through the phone. They pay the bills through the phone. They communicate through the phones. And they even do some kind of a development in the phone. That's why the apps are getting bigger. So every 10 years, the industry will have a major change. And the future will be extremely interesting. That's my short answer.
Thank you, sir. Thank you, sir. Sir, there is one more question. Shall I share it or otherwise?
Sure. Yeah, go ahead.
Fine, sir. There is a question from K. Mohammed Abdul Qadir, sir. Will there be any issue in balancing the frequency of running CA jobs and resource utilization?
Can you repeat the question? There will be.
Yes, sir. Will there be any issue in balancing the frequency of running CA jobs and resource utilization?
Very interesting question, Abdul. I really appreciate it. That's a thoughtful question too. There may be some imbalance getting created. It happened. You have it happened in my projects also. You create when you plan. I mean, you go back to this. You plan. That's a second stage in your software development life cycle. And when you plan it, you create the resources. You create the project plan. You load everything in the Primavera schedule, and then the schedule tells you. It just creates. The software comes out at the end. This is the date you will get everything done. But when it goes to the CA job, when you set up all the automated builds, you get so many problems in the build. You get so many problems in QA. You get so many things. The imbalance will come. For what reason? There will be mainly because of these two problems, these two things. Either project plan is not clear, or it is weak, or the resources are weak. So one of these two, or maybe both of them, needs to be revised. That's where the problem comes. And it happened in the past. And I've been to that stage. Imbalance comes, but you should be prepared to balance that imbalance very quickly. And that's the beauty of the CI/CD pipeline. And that's the beauty of the project development methodology. I'm pretty sure some of you may be familiar, and Abdul, you may be familiar too. It's agile, waterfall, iterative method. There are three different software management methodologies. Waterfall is you start from here and you get it here. Whereas iterative is you go back and make a loop. Agile is you be very quick. You build a small product, make it big. You build a small product, 2 week sprint. So that software methodology and this project plan and resources makes a big impact to address the imbalance. Good question.
Thank you, sir. Krishna Lakshmi ma'am, over to you. Hello.
Hi, ma'am.
Yes, ma'am.
Here's some network problem.
Oh, okay, fine, ma'am. Suganti ma'am is there. Suganti ma'am. Suganti ma'am.
Is there, ma'am? Yeah. Hello, ma'am.
Suganti ma'am, you can give a vote of thanks, ma'am.
Yeah, okay, ma'am.
I request Suganti ma'am, Assistant Professor of Computer Science Department, to give vote of thanks.
Okay, ma'am. Thank you, ma'am. A warm welcome to everyone. Dr. Abdul Kalam sir said, thinking is the capital, enterprise is the way, hard work is the solution. I'm honored and lucky to have the opportunity to propose a vote of thanks on this international webinar session. I would like to thank our resource person, Mr. R. Sendrikuma sir, Manager, Software Engineer, Amaranth Corporation, St. Louis, Missouri, USA. In spite of his busy schedule, for making an excellent presentation and also this webinar as a wonderful session and more interesting, where he mentioned the need for a recent trends in software delivery, CI/CD pipeline implementation. It is a backbone of the modern DevOps environment. I would like to thank our chairman, through S. Padam sir, managing directors, Mr. S.K. Tirukumaran sir, and Mr. S.K. Sendrikuma sir, beloved principal ma'am, Dr. N. Bhuma, and also to express our deep gratitude to our vice principal, Mr. Ramasamy sir, for his presence in this webinar. I would also thank our beloved HOD, Mrs. R. Jyoti, for her guidance and moral support. I'm very happy to express a vote of thanks to our technical team members, colleagues, and participants that has made this international webinar as a grand success. Thank you all. Thank you, ma'am. Hello, Maha ma'am. Yeah, Maha ma'am.
Thank you, Suganti ma'am.
Thank you, ma'am.
Thank you,
Thank you.
Suganti ma'am.
Thank you, ma'am.
Sir, whether we can wind up the session, sir?
Okay, thank you. Thanks for the opportunity. I am happy to answer any more questions if it comes from the participants. And it was my pleasure joining with you all this morning. And be safe, stay healthy. Thank you.
Sir.
Thank you.
Thank you.
Thank you, sir.
Bye.